Hi, welcome back to CC Tutor's GMAT instructional videos. We're going to go over a simple problem-solving sample so that you can get a feel for how we instruct here at CC. If n and p are integers greater than 1, 5n is the square of a number, 75np is the cube of a number. What is the smallest possible value for n plus p? So we're given three facts. 5n is equal to the square of a number with 75 and p. 75 is an integer, n is an integer, and p is an integer. So we can assume that this other unknown number, y cubed, is also an integer. So now with these pieces of information, we must determine what the smallest possible value for n plus p would be. Now in order to solve this problem, we need to know something about primes. Okay, so in order for us to remain valid here, we know that if we take the square root of 5n, that must be equal to an integer x. Okay, so in order for this to be true, we need n to contain at least 5 and something else squared. This something else could be anything that we want. It could be 2 squared, it could be 2 squared, 2 squared, 3 squared, right? Any number, any even number of primes, in addition to a single 5, are all that's required to be in the prime factorization of n. Because of this condition we discovered earlier, we know that n will not be equal to 1. We know that n must be greater than 1, so that it's got to have 2, 3, 4, 5, 6, 7, 8, 9, 10. But we need it to contain at least a 5 in the prime factorization, so that whenever we include it in this expression, the square root does evaluate to a whole number. So we know, right, that n must contain a 5 and may or may not contain something else, right? N could simply be 5. If n were equal to 5, right, then we'd have 25 equals x squared. Right? Now let's consider for 75 np equals y cubed. We need the cubed root of 75 np to equal an integer y. Well, let's break down 75. 75 contains 3, 5, and 5. Well, now what about n? N contains at least a 5 and may or may not contain something else. So when we consider this, we know that we have at least 3 5s inside of this expression, meaning that the 5 can come out, and what we would be left with is 5 cubed root 3 times whatever other factors, this could be a 1, right? Again, this is the same question mark, that are inside of n times p equals some whole number y. So now we don't really care about this 5 anymore. It's out of the way. It's taken care of. We don't really need to bother with what's inside of this question mark, right? Because since we're not required to have anything else here, it could be just 1 by this first condition that we were presented with, right? We have to make sure that this 3 can be brought out by the prime factorization, which is in p. But nonetheless, we know that the prime factorization of p must contribute at least 2 more 3's in order for this 3 to come out of the radical so that we can have our number y to be a whole number, right? So let's go for the case that, let's say there is no additional factor in the n, it is just a 1, right? Then what do we need the p to contain? We need it to contain at least a 3 times a 3, right? And then it can contain something else as well, but for now let's just consider that as a 1 because all we are required to have are these 2 3's, So then that would mean that n is equal to 5, right? Well, actually, technically, n is equal to a multiple of 5, but we've got several variables floating around here, so it may be a bit much to express another one, right? But n is 5 times some number that we don't know, right? But it is at least a 5, and we know that p is at least a multiple of 9, right? At the very least, p must be a multiple of 9, right? So that way, if we get that, we have 3 times 5 squared for 75 times 5 for n times 3 squared for p. That is equal to y cubed, such that y is equal to 15. Right? It's 3 and 3, 5 and 5. Both of them have an exponent of 3. What we would be left with is 1 5 and 1 3 when we take the cubed root, giving us 3 times 5, which is 15. Right? So at the very least, n is a multiple of 5 and p is a multiple of 9. So the smallest possible value for n plus p would be equal to 5 plus 9, or 14.